So today I'm going to briefly talk about Newton's third law. So the definition of Newton's third law is for every action there's an equal and opposite reaction. And so what this is basically saying is that a force of an object applied in one direction is opposed by an equal magnitude force in the opposite direction. So if something equals 5 newtons, the force back on that object will also be 5 newtons. A force is basically just a push or a pull on an object, and in this instance, force is equal to the mass of an object times its acceleration. So mass is always measured in kilograms in physics, and mass is basically the amount of matter inside an object. But in physics, we say that mass is the property of matter that measures an object's resistance to acceleration. And here acceleration is the change in velocity or the speed of an object. So the equation for the third law is the force of one object equals the negative force of the second object. And replacing the force with the equation that we had earlier, that force equals mass times acceleration, we can have in here that the mass times acceleration of the first object is equal to the negative mass times acceleration of the other object, and the negative indicates the opposite direction of the force. It's important to note that the equation is inversely related, so as the mass of an object is greater with a small acceleration, it would have to equal a if an object on the other side had a small mass, it would have to have a larger acceleration in order to balance out those two forces. And again, we still have the negative because it is in the opposite direction. So a real-world example that I did is I had a golf club right here striking a golf ball. So in the first case, the club is accelerating towards the golf ball. And then right here, they are meeting each other, so the force of the club is now being applied to the golf ball. So in this case, the force forward on the ball is neutralized or balanced by the force in the opposite direction of the golf ball. So the club is pushing a force onto the golf ball, and the golf ball is applying a force back onto the club. And then the ball moves forward because it has a smaller mass. And that moves on to the theory of conservation of momentum, which we're not going to discuss in this at this moment, but it is important for other type of physics. So a calculation that we could do is, this is hypothetical because using a club swing and golf is very complicated physics, but hypothetically, well, the mass would be 1 kilogram. That actually is the mass of the club. But it was difficult to calculate the acceleration of the club. So I've, based on some other research and things, I said it was about 7 meters per second squared, because I wasn't doing a full swing. But anyways, we could use the equation that we have to solve for the force of the club onto the golf ball. So in this case, we have the 1 kilogram, so the mass of the club, times the acceleration, so 7 meters per second squared equals 7 newtons. And so if you went back to the diagram before, we could show that the 7 newtons forward on the golf club has to equal 7 newtons back of the golf ball on the golf club, because those forces have to be equal but in opposite directions. And you can think about it, this makes sense, because if we had a large force of the golf club on a small mass golf ball, that would result in a very high acceleration, which is the reason why somebody could hit a golf ball 100 and some yards, 130 yards if it's an 8-iron. So that is Newton's third law.